Hello guys, welcome to AI in Space Tech. And in this channel, as I said before, I'm gonna be talking about AI and remote sensing and how these two worlds come together and how can remote sensing actually can benefit from AI and breakthroughs in AI. So in this first episode, I'm gonna be talking about I'm gonna have two different parts. One is gonna be about some news I found in the internet, which many of them are not even new because they date back on 2017. Nevertheless, I think it's important to mention them here. And then I'm gonna go on with the knowledge section where I'm gonna be analyzing one work from the academia. And in this first episode, I'm gonna be analyzing one of my papers which actually deals with big neural networks and how these can be used for the task of semantic segmentation, and actually how we can even improve these kind of systems by using an ensemble of them. Nevertheless, I'm going to analyze this in a while, but first I'm going to start with the news. So let's go on. And the first topic I'm going to talk about is intelligence community companies give out satellite imagery to motivate app developers. So SpaceNet is a repository of free imagery to lower the barrier to entry for developers and startups to access high-quality geospatial data. Okay, this is very interesting. Maybe some of you know about the SpaceNet. SpaceNet is actually a big repository for annotating data, and it came in the form of a contest. I will add all the links and we're gonna check them quickly here. But anyway, you can go later, download the data, play with them, and see what is this all about. So, giving away data to software developers have been a proven tactic for industries trying to create excitement and new products. The geospatial intelligence world is continuing the trend in a big way. At its annual symposium this week, the United States Geospatial Intelligence Foundation presented its Industry Achievement Award to SpaceNet, an open repository of free imagery with map features created by Cosmic Q Works, Radiant Solutions, and NVIDIA. What is very important to mention here is that big companies such as NVIDIA, which they are actually creating graphic cards, namely GPUs, which are used for deep learning, and these involves NVIDIA heavily with the AI community. It's interested also promoting this kind of technology into remote sensing. Otherwise, they wouldn't provide these big data sets for free openly. So NVIDIA is actually shows an interest in remote sensing community and AI by providing this kind of data. So SpaceNet was launched in 2016 in its first public release of multispectral satellite imagery of 50 centimeter resolution. It may be used for national security purposes, but the industry hopes to promote other applications of machine learning using geospatial data, such as humanitarian crisis response, ensuring the accuracy of maps used by self-driving cars, predicting earthquakes, and so on and so forth. Developers are invited to participate in SpaceNet challenges. 3 have been conducted so far. The 4th is coming up later this year and will focus on the identification of objects at high, if not near, angles of collections as opposed to straight down views to mimic imagery that may be collected by newer constellations with higher visit rates. The data repository includes over 5,700 square kilometers of digital globe imagery and more than 685,000 building footprints and more than 8,000 kilometers of road network hosted on Amazon Web Services. So, of course, the contest varies each year, but what is general is that the data are big. The training data provided along with the imagery are also very important, and probably took quite some time to create them. So 685,000 footprints on a pixel level, and probably 8,000 kilometers of road. These are a lot of data. Another data set that I found, it's the X-View Detection Challenge, and I'm gonna show you the link in a while. For finishing this article, some other information are that Robbie Schingler, co-founder and chief strategy officer of Planet Labs, said the industry wants to see disruptive tools. Machine learning has been around for many years, but algorithms get better with more data and more training. So, of course, what we see is that even big companies such as Planet Lab now, they're looking not just on the data, but on the machine learning aspect. So that's why I think it's important to present these kind of topics here, because as I said before, there's a big gap between what machine learning is doing in academia and what machine learning is doing in the applications, in the market, in the field of remote sensing. So this gap is quite large, and I would like to try to inform the community so this gap will probably shrink. Also, Robert Laudati, Managing Director of Commercial Products at Harris Space and Intelligence Systems, said that data is becoming free, easier to collect, and data vendors are moving into the analytical space to solve problems for customers. So what Robert Laudati says here is actually that the companies are not just interested anymore only on selling data, but they're also interested on actually providing some information from the data to their customers. So the companies themselves are looking into the machine learning aspects, because it's not enough just to sell the information, the images, as it used to be the case in the past, but now the customers want the information directly from the company. So, saying that, I want to show you quickly the different benchmarks, dataset, challenges, you name it. They can be all of these things. So the X-View that was mentioned before, you see here the 2018 detection challenge. This is object detection challenge, meaning like when you have an image such as this one, you have to detect the objects the annotator have annotated on the training data set, and state the type of object included in your bounding box. But you don't have to do a per pixel classification, so you just have to detect the object and name it. This is not an easy task when you have 1 million object instances, as we can see here, 60 different classes, and 0.3 meter resolution, so very, very high. And the total area which is covered by the data is 1,415 square kilometers. The challenge, it's almost closed, as you can see here, but nevertheless, probably you can download the data and play with them. What is interesting in this realistic scenario is the frequency of the classes. So we have 60 classes, and as we can see here, the utility truck is the most frequent. Then we have the vehicle lot, and then we have more rare classes such as helicopter, stadium, and so on and so forth. And as we can see here from this diagram, what is very important is that the frequency of the classes is very, very different. Nevertheless, you have to detect all of them. Moving on, we have the SpaceNet. that I talked before, and this is another very big benchmark data set, and probably this year we will having the 4th version of it, with very, very big areas and a lot of training data for annotating buildings and roads. And further on, we have also the functional map of the world, which is a challenge that finished earlier this year, but probably you can also download the data and play with it. This one was a challenge by YARPA, if I'm not mistaken. Somewhere is written. Nevertheless, the data are here, and I don't know why we wouldn't see more of these challenges in the future. So if somebody would be interested, nevertheless, what you need to do to participate successfully, I guess, into these challenges is to really educate yourself on the latest advances on AI and remote sensing, and what I will be doing here. So these are all the data sets I quickly found. Of course, there are more, but I'm gonna add all these articles and these data sets into the description section of this video so you can find them easily.